Hi everyone. Today I will be presenting on graph-based matchmaking in matrimony applications. This topic explains how graph theory concepts are used in modern matrimony platforms to suggest compatible partners. Instead of manually searching through thousands of profiles, matchmaking platforms use graph models and algorithms to analyze the compatibility and recommend suitable matches. In this presentation, I will explain how user profiles can be modeled using graphs and how algorithms generate stable matches. In this presentation, I will cover four main parts. First, I will introduce the concept of graph-based matchmaking systems and explain the problem they serve. Next, I will explain the graph theory concepts used to represent user profiles and compatibility relationships. Then I will discuss the algorithms used to generate stable matches, particularly the stable marriage algorithm. Finally, I will present a case study and a real-world application where graph-based matchmaking is used. Modern matrimony platforms contains thousands or even millions of users. Manually browsing through these profiles to find a compatible partner can be difficult and time-consuming. To solve this problem, platforms use automated matchmaking systems. Graph theory provides a structured way to organize user profiles as networks of connections. In this approach, users are represented as nodes or vertices. Compatibility between users is represented as edges. Algorithms analyze these connections to determine the most suitable matches. In graph theory, a graph consists of vertices and edges. A vertex represents an entity, while an edge represents a relationship between two entities. In matchmaking systems, each user profile is represented as a vertex in the graph. If two users are compatible based on their preference, an edge is created between them. The strength of this connection may depend on compatibility factors such as age, education, and interest. Graph algorithms then analyze these connections to generate partner suggestions. A bipartite graph is a type of graph where the vertices are divided into two separate groups, and edges exist only between the two groups. In matrimony applications, one group represents male profiles and the other group represents female profiles. Connections are created between only these two groups. This structure simplifies the matchmaking process because it organizes the profiles into two clearly defined sets, making compatibility analysis more efficient. This slideshow shows a simple example of a bipartite graph representation. On the left side, we have a male profiles A, B, and C. On the right side, we have female profiles X, Y, and Z. Each line between them represents a possible compatibility connection. In this example, every male profile is connected to every female profile, meaning that all possible matches are considered initially. Later, algorithms analyze these connections and determine which pairs are the most compatible. Not all matches have the same level of compatibility. Therefore, each connection between two users is assigned a compatibility score. This score is calculated using different factors such as age compatibility, education level, profession or job, religion or community, location, and personal interest. This goes from what it is called as a weighted graph, where each edge has a weight representing compatibility strength. Higher weights indicate better matches, allowing the system to rank potential partners. To generate fair partner matches, matchmaking systems use the stable marriage algorithm, also known as the Gale-Shapley algorithm. The main goal of this algorithm is to produce stable matches. A matching is considered stable if there is no pair of users who would both prefer each other over their assigned partner. The process usually follows these steps. First, the system creates a bipartite graph of profiles. Then, compatibility scores are assigned. Next, preference lists are created based on these scores. The stable marriage algorithm is then applied to generate the final stable matches. Graph-based matchmaking is widely used in modern platforms. Examples include matrimony websites such as Shadi.com, Bharat Matrimony, and Jeevan Shadi. The dating application like Tinder and Bumble also uses recommendation algorithms that analyze compatibility and preferences. Let us consider a small case study. Suppose we have three male profiles A, B, and C, and three female profiles X, Y, and Z. After applying the stable matching algorithm, the system produces matches such as A paired with Y, B paired with Z, and C paired with Z. These matches are stable because no unmatched pair prefers each other more than their assigned partners. Graph-based matchmaking systems provide several important advantages. They generate systematic and structured partner suggestions. They reduce the time users spend manually searching through the profiles. They can also handle very large database efficiently, which is important for large matrimony platforms. Most importantly, the use of algorithms ensures stable and reliable matches, improving the overall user experience. In conclusion, the graph theory transforms matchmaking into a scientific and algorithm driven process where users are represented as nodes, compatibility as edges, and algorithms generate the optimized partner matches. Thank you.